In example 2D, the equation is y equals the cubed root of x. So we are going to find the intercepts algebraically, and we're also going to graph this equation by hand. But before we find the intercepts, I want to take a minute to make sure you understand what a cubed root is. So let's start with something familiar, not a cubed root. Let's look at a square root because that's what's familiar to us, okay? If I asked you what the square root of 25 is, okay, that means you're looking for a number that if you multiply it by itself twice, you get 25. Okay, so the answer here is 5 because if you take 5 and you multiply it by itself 2 times, you get the number underneath the radical, 25. Okay, so when you see this notation, you see like it looks like the square root symbol, but now it's got a little 3 above it. Okay, that's referring to a cubed root. Okay, we don't know the cubed root of 25 off the top of our heads, so let me give you a number that you will be able to calculate the cubed root of. Okay, so let's look at the cubed root of 27. All right, so what this is saying, this is going to equal some number. Okay, we're looking for a number that if you multiply it by itself 3 times, okay, then you're going to get the number underneath, which is 27. Okay, so here the answer is going to be 3, because if you take 3 and multiply it by itself 3 times, 3 times 3 is 9 times 3 is 27. You'll get the number underneath the radical sign. Okay, the little number here is called an index. So a cubed root has an index of 3. A square root has an index of 2, but we never ever write it. Okay, but it's understood to be 2. Okay. All right, so hopefully now that makes better sense. If you had forgotten what a cubed root was, hopefully now you know. All right, so let's get started here with intercepts. So let's start with the x-intercepts. Okay, so we need to set y equal to 0 and solve for x. Okay, so here we go. Go to your original equation, y equals the cubed root of x, and everywhere you see a y, you're going to replace it with 0. Okay, so we're going to get 0 equals the cubed root of x. Okay, we need to solve this for x. Okay, so again, we are mostly familiar with square roots. Okay, had this been a square root, you would probably tell me, okay, to get x by itself, to undo the square root, you're going to square both sides. Okay, so it's the same kind of thing here, but with a cubed root. Okay, if you're trying to get rid of the cubed root because that x is trapped in the cubed root, to undo a cubed root, you're going to cube both sides. Okay, so let me write this again. Okay, and so to get rid of the cubed root, what undoes a cubed root is cubing that term. Okay, so the cubed root and the cube, which means raising it to the third power, they undo each other. Okay, if you raise the right side to the third power, you have to do it to the left side. Okay, so on the left side, the cubed root and the cube cancel. That leaves you with x. The left side is going to be 0 cubed. That means 0 times 0 times 0. That's just 0. So you're going to get that there's one x-intercept, and it is 0. Okay. All right, so let's write this down as an ordered pair. So here, the x value is going to be 0. And then we know for any x-intercept, the y value is going to be 0. So the origin here is the x-intercept. And I'm going to go ahead and plot this point because it will be on the graph. This is going to be the x-intercept of the graph. All right, so now we need to determine the y-intercept. So for the y-intercepts, we need to set x equal to 0. All right, so let's do that. Go back to the yellow equation, the original equation. Everywhere you see an x, you're going to replace it with 0. So we're going to get y equals the cubed root of 0. All right, so this is going to tell us that y is equal to 0. The cubed root of 0 is 0 because 0 times 0 times 0 is equal to 0. If you take 0 and multiply it by itself 3 times, you're going to get 0. So the y-intercept is going to be 0. If we wrote it down as an ordered pair, remember the x-coordinate has to be 0. That's true of any y-intercept. And we just calculated that the y value has to be 0 as well. So the origin is both the x-intercept and the y-intercept here. And that's okay. If it's the origin, you know, it could be both an x-intercept. If your intercept is the origin, it's going to be both an x-intercept and a y-intercept here. So don't let that confuse you that it is the same point. That is possible. All right, so as far as how our graph is looking, we know that the graph contains the origin. Okay, we need way more points to figure out what this thing really looks like. So we are going to need to make a table of values here. All right, so let's go and do that. All right, again, you are in charge of x. So I'm going to set up the table. So in the first column, I will let that be x values that we pick. And then what we will do is take each of those x values and plug into the original equation to calculate the y value. So the equation is, again, y equals the cubed root of x. And then once we have the y value, that will give us an ordered pair, and we can go ahead and plot that point. All right, so here we go. Well, I'll put point. Okay, so let's look at what we're dealing with. Okay, so this picture of the graph, the grid, you're in charge of x values. We need to pick x values. So if you go from left to right, the leftmost x value is -10 and the rightmost x value is +10. We're not going to sit here and plug in every single x value from -10 to 10. Okay, you need to be smart about this. Okay. For example, if you did plug in, well, let's do it this way. Say you plugged in 10, okay, the rightmost x value here on the grid. If my x coordinate is 10 and I plug that in to get the y value, that's going to tell me y is the cubed root of 10. Okay, that you probably don't know that off the top of your head, and you shouldn't, because it's some nasty decimal. Okay, so we don't want to use that x value. We want to plug in an x value such that if we plug it in, we get a nice number out. We don't want a decimal as our y value. Okay, so you want to think of something, and again, you're only plugging in x values between -10 and 10 because those are the x values that fit on our graph. You want to be able to plug in an x value and get a nice number out, not a decimal. Okay, I am going to start with the positive x values. Okay, we already know that if we plug in 0 as our x value, so I'll put that somewhere in the middle here, we're going to get y is equal to the cubed root of 0, and we know that that's 0, and so that the origin should be on the graph here. Okay, so let me pick 1. Okay, so now if I pick x equals 1 and plug it in, this is going to be the cubed root of 1. Okay, and that is just 1, because if you take 1 and multiply it by itself 3 times, you get 1. Okay, so the cubed root of 1 is 1. So that means if x is 1, the y value is 1. So 1, 1 is going to be on the graph. Okay, all right, so then you want to keep plugging in other values. Okay, do you know the cubed root of 2? No, it's a decimal. The cubed root of 3? Don't know it. It's a decimal. Cubed root of 4, cubed root of 5, cubed root of 6, cubed root of 7. All of those guys are decimals, so we're not going to use them. Okay. Finally, if you look at 8, okay, we can use 8. Okay. There, the cubed root of 8 is nice. It is 2, because if you take 2 and multiply it by itself 3 times, you get 8. Okay. So the cubed root of 8 is 2. So if you plug in x equals 8 to the cubed root equation, your output or your y value will be 2. Okay, so 8, 2 is going to be on the graph. Okay, so let's go ahead and plot these points. Okay, so we know the origin 1, 1, and then 8, 2. Okay, remember all other x values between 0 and 10 that we don't have a point for, if you plug those x values in, you'll get a decimal result, so we don't want those. Okay, now let's talk about the negative direction. Can your x values be negative? Okay, the reason I'm asking this is because think about square roots. Okay, when we're talking about cube roots now, but I'm trying to always tie it back to square roots because they're more familiar to us. If I asked you what the square root of -25 is, okay, you should tell me error. because you cannot take the square root of a negative number. That is not allowed. Okay, you can't do this. Okay, but is that true of a cubed root? Can you take the cubed root of a negative number? Well, let's think about it. Okay, so let's go in the negative direction. So what if I said x is -1? Okay, well then I'm going to plug it in. Y would be the cubed root of -1. Okay, can you do that? And the answer is yes. The cubed root of -1 is going to be -1. Because if I take -1 and multiply it by itself 3 times, 1 times 1 times 1 is 1, but look at the signs. Negative times negative is positive, times negative is negative. Okay, so -1 times -1 times -1 is -1. So the cubed root of -1 is -1. So if x is -1, the y value is going to be -1. Okay, so if you plug in -2, okay, you can do that. You can take the cubed root of -2, but again, it's going to be a nasty decimal. Okay, same thing with cubed root of -3 and so on. Okay, as far as our x values between -10 and +10, there is one more thing we can plug in for x, and that's going to be -8. Okay, so if we try to compute the cubed root of -8, that's going to be -2, because if we take -2 and multiply it by itself 3 times, we're going to get -8. Okay, so if x is -8, the y value or output is -2. Okay, so we have 2 more points to add to our graph here. -8, -2, and then -1, -1. Okay, all right. I am going to go ahead and connect the dots here. Okay, I call this guy the snake graph. Okay, because it's going to look like a snake. Okay, so give me a second to draw this in. All right, so this is the graph of the cubed root of x. Okay, this is going to come back. This graph is, you don't have to memorize it right now. It's actually really good if you remember how to come up with it by making a table of values. But this graph will come back in section 3.4, and you will have to memorize it. You will have to know specific points on the graph and be able to draw the graph out by hand. Okay, so just kind of remember this. You don't have to know it now, but at least you've been exposed to it. So if you see the graph of y equals the cubed root of x, it is that snake looking graph. Okay, both the x-intercept and the y-intercept here is the origin.